Let's have a look at the liver. We're going to talk about the segments in syntopy. So there's really two kinds of segmentation if we talk about the liver. The first one is based on the four lobes that we know about. So the right lobe, which is the biggest lobe, and it's located on the right side of the left sagittal fissure. And then you have the much smaller flattened lobe, which is your left lobe, and it's on the left side of the left sagittal fissure. Then you have the quadrate lobe, which you can see in the inferior view right here in the yellow, and it's between the gallbladder and the fissure for the ligamentum teres hepatis, which is the round ligament of the liver, and it's located below the porta hepatis. And then you have the caudate lobe, which is right there on the top in purple, as you can see, and it's between the fissure for ligamentum venosum and the inferior vena cava, above the porta hepatis. Now, we'll talk about the porta hepatis soon, and before that, I just want to give you something that I studied with, which is C comes before Q. If you ever have a doubt in which is superior, which is inferior, then remember that C comes before Q. So caudate lobe on the top, C, and then quadrate lobe, Q, below. Let's have a look at the ligaments. You have two different views here. One is the anterior aspect, and one is the superior view, but they kind of just discuss the same ligaments that you'll see, which is the right and left triangular ligaments, and then the round ligament of the liver. You also have the falciform ligament, and then the coronary ligament. And the other classification that I was talking about is based functionally, which it uses the vascular supply and the biliary tree in the liver, and then you get 8 different functional segments. This is also known as the surgical conoid classification of the liver, and this sort of doesn't correlate with the pattern of lobes you see, which means if I held a liver in my hand, I'm not going to see these 8 segments, I'm just going to see the lobes that we talked about, which is why we say that this is more of a functional classification, that it does not correspond with the pattern of lobes that you see from the surface itself. And this is usually used in a more surgical aspect. And you see them a little bit more clearer here in this picture, and just going through them is enough. They will probably ask you, and yeah. Now let's talk about the syntopy. So you may know that syntopy is basically the position of an organ relative to other organs, or in simple terms, whatever is nearby that certain organ in an anatomical relation is the syntopy. So if you see the visceral surface of the liver, you'll see it has relations with the right kidney. So it will have a renal impression, then you have the gallbladder, the right suprarenal gland, the superior part of the duodenum, the right anterior part of the stomach, the lesser omentum, and then the right colic flexure, as well as your transverse colon. So if you see on the liver, you will find impressions for all of these organs in terms of where they, are in contact with the liver. And the previous slide talked about the porta hepatis, which is your transverse groove, and that is basically the position where the hepatic ducts emerge from the liver, and then there's an entrance of the nerves and vessels. So basically, do you see in the picture that you have the hepatic portal vein, the hepatic artery proper, and then the duct, the bile duct? So that area where all of these are entering is basically the porta hepatis. So just keep that in mind. And then the diaphragmatic surface of the liver, we'll talk about syntopy in terms of this too. So mainly you have the diaphragm. So the entire diaphragm is, sort of just located on the liver. It's all in contact with each other. And then you have a cardiac impression too, which is the area where the heart will rest against the liver. And now let's talk about the structure, nutritional, and vascular bed, and then the intrahepatic ducts. So as we saw before, this is just an anterior and posterior view of the liver. We sort of touched over the ligaments. We looked at the porta hepatis, and let's look at the bare area or the area nuda. Basically, it's one of the main fixation points for the liver that's relevant clinically. But what exactly is the bare area of the liver? It's the part of the liver that has no peritoneal covering at all, and it's found on the posterior superior surface of the right lobe, and it's basically gonna help to anchor the liver in place. It provides stability and support, and that's the main relevance. And then here you see the portal triad, quite important, made up of the common bile duct, the hepatic artery, and the portal vein. And you will also see the intra and extra hepatic ducts, mainly in this picture, kind of just the extra hepatic ducts, but we are going to look at the intrahepatic ones very shortly. So in this picture, only the right hepatic duct and the left hepatic duct are a part of the intrahepatic ducts. And before we go to the ducts, we will look at the liver's blood supply. It has a sort of dual blood supply, one being functional and one being nutritive. So if you see the hepatic artery, it will bring oxygenated blood to the liver, and it's very essential for the liver tissue because it has so many functions, as you'll see in physiology next year. But this oxygen-rich blood is really essential to the liver. So that's brought by your hepatic artery, and that is a branch of the common hepatic artery. And then you have your hepatic portal vein. It will deliver nutrient-rich blood from the GIT and from the spleen, and it's going to help with liver processes and then circulate throughout the body. And now the intrahepatic bile ducts. You have the canaliculi, which is basically for the bile production. Then you have intralobular and interlobular bile ducts, as well as the right and left hepatic ducts. And these are what leave through the porta hepatis and then will go join to the common bile duct, as we saw in the previous picture. And that was briefly the liver.